For this semester's Algorithm Theory and Design video project, we chose to take a close look at the Bellman-Ford algorithm. The Bellman-Ford algorithm is a graph search algorithm that finds the shortest path between a given source vertex and all other vertices in the graph. This algorithm is used in distance vector routing protocols, for example, the Routing Information Protocol, or RIP for short. In other words, if we think of a network as a graph and the vertices as routers within that network, the Bellman-Ford algorithm is run on that graph to find the shortest routes between routers, making the flow of information packets throughout the network as efficient as possible. This very idea is what brings us to our case study, network routing. Keeping in mind that the overall goal is to find the shortest path between routers for the flow of data packets, we'll take a closer look at how the Bellman-Ford algorithm actually achieves this. Bellman-Ford is based on the principle of relaxation. This means that calculated approximations of the distance between routers are made each time a loop of the algorithm is run. These approximations are an overestimate, which are updated with more accurate values at each loop until the optimal distances are all calculated. In short, the algorithm gets a value for each path, which is a calculated distance between two routers. Each loop recalculates these values, and if a shorter value or distance is found, the value is updated to its new shorter distance value. The algorithm loops over the graph v minus 1 times, where v is the number of vertices in the graph, or in our case, the number of routers in the network. The algorithm runs in big O of v times z, where v is again the number of vertices or routers, and e is the number of edges or paths between routers. Here's the pseudocode for the Bellman-Ford algorithm. Feel free to pause the video if you wish to analyze the algorithm in further detail, but for now we'll move on and discuss distance routing protocol more specifically. As mentioned before, Routing Information Protocol, or RIP for short, is a distance vector routing protocol that is based on Bellman-Ford and uses hops as routing metric. You can think of hops as the number of routers in between two routers of which you are currently trying to find the distance between. These hops are the routers that data packets will have to flow through in order for one router to communicate with another. This method isn't ideal, however, because the maximum number of hops is 15, but we'll get more into some negative drawbacks later. For now, let's look at this simplicity and how it has positively affected society. Cisco, a leading corporation in the deployment of network hardware, has a subdivision called Cisco Networking Academy, which offers a multitude of online courses to teach students about networking basics. Because of RIP's simplicity, it is a very useful tool to use to teach students networking basics. More complex ideas are too difficult for beginners to understand, so the simplistic approach that RIP takes is ideal for new students to learn the fundamentals of networking. Now, that's not to say that this simplicity is without its negative impacts. These negative issues have affected individuals a multitude of times over. RIP is so simplistic that it leads to easily exploited vulnerabilities, which allows for people to launch DDoS attacks across the internet. DDoS attacks, or distributed denial of service attacks, are attacks where users are flooded with information packets so they are not able to connect to anything outside of their own personal device. Granted, RIP was introduced in the late 80s, so it's not surprising that this protocol has become obsolete over the years. However, it has been built upon, with Cisco once again making use of this dated protocol. They have developed the Interior Gateway Routing Protocol, or IGRP for short, by building off the fundamentals of RIP, and is most commonly used today to exchange routing data within an autonomous system. Even after developing this, Cisco has continued to upgrade IGRP, and this has not come without its benefits. From early 2006 to late 2007, Cisco's net worth doubled because of an update release of IGRP called EIGRP.